So welcome back. Hope you enjoyed lunch, and hopefully this is all starting to make some sense. So I have a couple quick announcements to make. I was talking to a couple of you over lunch, and you asked about the slides and the samples. So those are all going to be available to you. So if you want to take a look at the slides, they're going to be on the post-conference CD. All the samples that you've seen are available on ComNet. So if you want to head over there, you can take a look at those things now. The other thing is that if you want to go play with this stuff, sign up for the hands-on lab. All of this technology is installed. We have some tutorials that you can walk through, and you can start getting up to speed. So with that, let's get right back into the details. So in the last session, what Mark Anders walked us through was the .NET application model. And the thing that I hope you took away from that was just how easy this is going to be. What Mark walked us through is how we can use web services to pull things together. We can treat that data, whether it be XML data or relational data, as an entity that we can project the UI from, or we can project web services out. And it's pretty straightforward stuff. The runtime takes care of handling all that web service plumbing, the SCL, the SOAP discovery, and so on, all for us. Now, there were a couple key innovations that we introduced in the last talk, and I hope you identified those and have been thinking about them over lunch, which is there were two. The first one was the ability for these server controls to target different kinds of incoming requests. So if a browser comes in that has the ability to do menus and things like that, those server controls can automatically take advantage of it. If it's a device like a PDA or a cell phone, we have a set of server controls that can automatically target those things and do the right kinds of behaviors. We think that that will save you a whole bunch of time. You can use a single programming model, the same set of business objects, and be able to target the widest array of devices and browsers and UIs. Everything from the simplest cell phone up to the richest possible displays. The second major innovation was that personal tier thing. So what we did was we created this app, the FM Expense, and then we took that same programming model and we brought it offline. So you'll be able to take your applications and bring them offline. Now, I don't want to pull the wool over your eyes on this. You're still going to have to do some programming to do things like the synchronization, to detect when you're connected and when you're not connected. But the model, that fundamental .NET programming model, is going to remain consistent whether you're working in an online mode or whether you're working in an offline mode. You're still going to be handling the same kind of events. You'll be setting the same set of properties, and you'll have your application up and running. So we hope that that will also save you a bunch of time and let you build applications that have been very difficult to build to date. And all of those technologies are being built into things like IE to make this possible. Okay, so now what we're going to do is we're going to go down to the next level. So I think you probably saw how almost a novice programmer would be able to create a web service, assemble web services, project UI, and so on. But now we want to go and talk about the underlying framework that's going to enable all this. And so we're going to focus in on the .NET framework. We're also going to talk about Visual Studio.NET and how it's been constructed from the ground up to target this .NET framework. So to start this off with, I'd like to introduce Anders Hejlsberg. Now, Anders Hejlsberg, back in 1983, single-handedly wrote Turbo Pascal, licensed it to Philippe Kahn, and that was kind of the basis for the modern IDE. Borland sold this. It was a great thing. Anders went to Borland, and then he kind of brought the development process to even the next level in Delphi. With Delphi, what Anders did was he took a compiler, a set of integrated designers, a really deeply integrated object-oriented class library, a framework, and he brought all those things together to build a very compelling development experience. And so you'd think that after doing all this stuff and having licensed Turbo Pascal to Borland, that Anders was probably ready to retire to his own private island somewhere. But we came and we talked to Anders and we said, hey, we're going to build this next generation platform, and we're going to need an integrated class library for that. We're going to need to be able to target that. And we think it's going to be a new way to develop applications, and Anders was very excited about this. He agreed to work with us, and since coming to Microsoft in 1996, he's been working on the programming languages and the frameworks to pull all this stuff together. So Anders, in conjunction with some other distinguished engineers like Mike Tatangi, who built the core security and infrastructure that all this ran on, built this .NET framework. So that's what I want to talk about now just for a second. We've been talking about these things in the large. We've been talking how web services interact with each other. What we're going to do now is we're going to zoom in on that. And we still have all the ability to target the COM interfaces that have existed before. And in fact, we're making big investments in that space with things like the ATL server code that lets you get right down to the lowest level of IIS and make changes. But this is where we're going to spend a whole bunch of time now. We're going to focus in on this common language runtime. Anders is going to go through some of the innovations there. And then he's going to talk about how we pulled this all together to build the components that underlie this system. So please welcome Anders Hejlsberg. Anders? Great to see you. Good luck.
Thanks, John. Thank you, John. My name is Anders Hejlsberg, and I'm a distinguished engineer at Microsoft, and I've spent the last 2.5 years working on some of the stuff that you're here to see today. You've seen this roadmap in John's slides, and this is going to sort of serve as my roadmap for the talk here. What I'm going to drill into is the next level down of these boxes that John has shown you. The common language runtime, which is the common infrastructure upon which the entire .NET framework is built. And then on top of that, we have our class libraries, the base class library, data and XML, web services, user interface. Further on top of that whole stack, we have our programming languages, and they're all built to a common language specification that basically defines a set of language features that you can expect to have available in every .NET programming language. And then finally, supporting the whole platform is Visual Studio. So I'm first going to drill into the common language runtime. And let me start off by giving you some of the design goals that we have for the common language runtime. First of all, when we built this runtime, we of course wanted to support multiple programming languages. We also wanted to dramatically simplify application development on the .NET platform, and we wanted to provide a robust and secure execution environment for your code. And finally, of course, we wanted to do something to simplify deployment and management of your applications. Before I go into sort of the technical details of the runtime, let me try and give you an idea of the evolution that has led us to this solution. What you see here on the slide, you can think of as representing one machine or one tier in a .NET application. And basically what each box represents here is an application, and within the application you have code and data structures. And before COM, applications were basically completely separate entities with little or no integration. At best, perhaps, you could share data between applications using files, comma-separated files, or whatever. But there was clearly a need for deeper integration. And therefore, we launched COM. And COM is about interoperability between applications. Applications can expose interfaces that can then be consumed by other applications. But COM is specifically not about the internal architecture of applications. Whereas, say, C++ supports classes and inheritance, constructors, operator overloading, and so forth, COM doesn't have those features. And in order to expose functionality out of an application through COM, you have to write a COM wrapper, which is what the graph here illustrates. Now, the problem with that is that there is some loss of fidelity as you put this external interface model on your application. And of course, there's also more work to do because you have to write these wrappers and all of the plumbing and housekeeping that comes along with them. Now, that probably wouldn't be such a big deal if all we were doing was interoperating big applications. But if you look at where software development is going these days, it's actually more and more about building finer-grained components and less about building coarse-grained monolithic applications. Examples of finer-grained components might be, a control hosted in a browser. It might be a business object running in Microsoft Transaction Server. It might be a stored procedure in SQL Server. Or it might be some code hosted in an ASP page. Now, common to all of those components is the fact that they are not monolithical applications. They don't start from scratch every time you write one of them. Rather, they're hosted in rich environments that want to make functionality available to those components. And to get to really the next level of productivity in those environments, we need something that is more full-featured than COM. To build new applications, what better metaphor to use than classes and inheritance, where you can actually take a starting point, inherit from it, specialize it, and so forth. And also, your applications really have sort of migrated from being these, monolithical things to being several pieces that are spread out in several different hosting environments. And one of the things that's really needed in between all of these environments is high-fidelity integration between the components, no wrappers, and also common APIs across all of the environments so that, if you are writing a control or if you're writing a stored procedure in SQL Server, you have the same APIs available across. And that's what the .NET framework is all about. The .NET Framework Common Language Runtime provides a common substrate upon which all programming languages are built and upon which components are built in the system. The framework is rich enough to express the constructs that you're accustomed to in programming languages, in object-oriented programming languages. The framework completely supports classes, inheritance, methods, properties, events, polymorphism, constructors, etc., etc. Furthermore, when you build components in this way, there's no difference between the component itself, its internal structure, and its external interface. It's one and the same. There are no wrappers in this world. The classes that you operate on in programming languages for the .NET framework are the very same classes that the system sees, and they're the very same classes that other programming languages see. There's no plumbing. The objects can directly interact. Now, once you have a model where all of the programming languages share this common substrate, then you can start putting services into the substrate. Services such as garbage collection, exception handling, threading, debugging, security, etc., etc. And you can start building common APIs that can be shared across components, across programming languages. So as I said up front, one of our key design goals was to simplify development. And the .NET framework, the Common Language Runtime in the .NET framework, completely eliminates all of the plumbing that you've had to deal with when writing COM components before. There's no registration, there are no GUIDs, there are no idle files, no H results, no IONknowns, no add refs and releases, no co-create instances. It's all gone. Thank you. Well, of course, that brings about the question, well, where did it all go? So let me try and talk about what some of the technical solutions here are. First of all, there's no need for registration because applications and components in the .NET framework are completely self-describing. They have their own internal structure. There's no need to put pieces of them into the registry so that classes can be instantiated and so forth. There are no GUIDs because we have adopted a hierarchical naming scheme with human-readable names. There are no idle files because there are no wrappers, and the programming languages natively understand the object model that the runtime provides. So when you are creating a class in your programming language, be that VB, C++, or C#, it is one and the same class that the system understands, and therefore you don't need the IDLE mapping at all. There are no H results because we are using structured exception handling for all error handling. There's no IUnknown because objectness is ephemeral in this system. The root object automatically is also the IUnknown or has the equivalent functionality. There's no add ref and release because we have automatic lifetime management through garbage collection, and co-create instance simply becomes the new operator in your programming language. So as you can see, the platform really is object-oriented to the core. Classes and inheritance are fully supported, even across languages. You can write classes in one language, inherit from them in another, implement interfaces in a third, etc., etc. Now, we do realize, however, that you're not just going to run out and throw away all of your existing code. It is super important to have seamless integration with code that already exists. And any .NET class that you write in the Common Language Runtime can be used as a COM component or a COM class outside of the .NET framework with zero extra work. It is simply automatically done by the runtime. And likewise, any COM class that exists today, you can import and use as a .NET class. So what is this box that we call the Common Language Runtime? Let me try and here in this slide just give you an idea of some of the components that are in there. The good thing about this slide is that you don't actually have to understand precisely what these components do. You never really physically see them, but it gives you an idea of the richness that the runtime provides. At the bottom of everything, we have the class loader, which manages loading and layout of classes, managing metadata. And then on top of that are some of the lower level core services like the CPU-independent intermediate language to native code compilers. There's a code manager that manages execution. There's a garbage collector that gives you automatic lifetime management of all of your objects. And then on top of that, we again have higher level services such as threading, type checking, security, marshalling to and from COM, exception management, and debug engine. And then even further on top of that is code that is integrated with the runtime but that supports the base class library, things like reflection and so forth. Now, as I said, another design goal was to enable you to build robust and secure applications. And key to that is automatic lifetime management. In the .NET framework, all objects are garbage collected. That means no stray pointers, no circular references, no leaks that you can't detect. Now, I know that you all may have an adverse reaction when you hear the word garbage collection. Why do I need garbage collection? I want my own memory manager. And trust me, a lot of us had that very same reaction to this problem. But if you, again, go back to what I was talking about before, applications are gradually becoming componentized. They are actually not monolithical things, but little pieces that are hosted in various environments. And really, for that to truly work and for productivity to truly be raised, you need some sort of memory management scheme that spans the entire platform. And the memory management scheme we've used in COM so far, add, ref, and release, has some serious problems like circular graphs that you can't break. And really, garbage collection is the right answer to this problem. So to convince ourselves, we really worked hard. We ran the numbers on this. We ported applications. We ran them with both models of memory management. And the numbers don't lie. The garbage collector that's built into the .NET framework is truly a unique piece of technology. Just as one data point, I could tell you that the average allocation and deallocation of an object averages out to about 40 to 50 clock cycles in a typical application. And I know of no memory managers that do better than that and give you all of the benefits that you get with automatic garbage collection. Another interesting data point is that the garbage collector in the common language runtime is probably the first industrial strength scalable multiprocessor garbage collector. When you're running on multiprocessor boxes, the garbage collector will actually spread the work of collecting the heap out between the different processors, which is quite a unique feature that gives you wonderful scalability. Another key point in writing robust code is having good error handling. And error handling in the .NET framework is done through structured exceptions. It's a first-class concept in the framework and in the programming languages that support the framework. It is specifically not about returning bools that said whether an operation succeeded or not, or returning opaque H results that are hex numbers starting with 8,000, and you have no idea what this number means. Rather, with structured exceptions, you get dramatically improved error handling. And an exception carries along with it, first of all, a descriptive name. It carries along with it context, such as an error message. And it permits you to get a stack dump that shows you where the exception occurred, why it occurred, and so forth. And finally, we've integrated the exception handling in the .NET framework with the structured exception handling in Windows, so you can actually even catch exceptions across, NT, across multiple processes. In the .NET framework, we have several compilation models for code. There's the native code compilation model that Managed C++ uses, which basically compiles your source code direct to x86 native code. But then we also support MSIL, or the Microsoft Intermediate Language, which is used by Visual Basic and by the C# compiler. Now, I want to make one point absolutely clear here, that whenever you're running code in the .NET Common Language Runtime, you are not interpreting that code. This is not an interpreted environment. Code is always run as native code. The only thing that really changes is when does compilation occur. If you take Managed C++, compilation occurs directly from source to native code. If you take VB and C#, compilation goes first to intermediate language, and then at install time, when you install your application, we can compile it to native code at that point, or we can compile it to native code dynamically as the application runs using a just-in-time compiler. But in all cases, you're running native code. Now, one of the key aspects of having an intermediate language is that you can define a subset of the immediate language that you can verify to be correct. And we do indeed provide code verification in the runtime. And once you can verify that code is correct, i.e. that it doesn't push an int on the stack and pop an object reference, then you can guarantee type safety. And type safety means that in an application you can perform no unsafe casts, you can have no uninitialized variables, you can have no out-of-bounds array indexing. All of that stuff is checked by the type checker and the code verifier. And once you have code verification and type safety, then on top of that, you can build a security system. And the .NET framework does indeed provide a security system that allows you to write secure applications based either on identity of code or identity of users or a combination thereof. And I just wanted to mention also that the permission set in the .NET security engine is extensible. You can build your own new permission sets and so forth. Now, all of these things, by the way, we have multiple talks on all of these key features of the platform throughout the rest of the conference. As I said, the .NET framework is a multi-language platform. We truly believe in giving you the freedom to choose your programming language. And all of the features of the .NET platform are available to all of the programming languages that run on the platform. You can write application components in multiple languages, so you can leverage your skills. If you're a skilled VB programmer, there's no reason to learn a new language to use this platform. Likewise, if you're a C++ programmer. Indeed, even if you're a COBOL programmer or an APL programmer. Now, not only does that preserve your investment and your skills, but it also gives you highly leveraged tools. Things like debuggers, profilers, code coverage analyzers, all work for all of the language and give you cross-language coverage because the runtime is rich enough to expose all of the information to these tools that they need. Another design goal that we had was to simplify deployment and management. And a word you'll hear over the course of a lot of the talks here at the conference is this thing that we call assemblies. And assemblies are really sort of the physical packaging of your code. They're the unit of deployment and versioning and security in the .NET framework. And they're in a sense like DLLs, but they're self-describing through a manifest. In other words, an assembly describes to the platform its dependencies on other assemblies. It describes what it contains in terms of classes and resources. And the system can, in a sense, perform analysis on these things to figure out precisely what is needed to run a particular application. Now, we understand that DLL hell has become a real problem. And trust me, that was right up top there with our design goals. And we've labored really hard to enable zero impact installation of your applications. And literally, with the .NET framework, if you have an application, if you don't want it to be shared, you can create a subdirectory, copy it in there, run it, and when you're done with it, you can delete it. There's no registration required whatsoever. Thank you. But perhaps what's even more interesting is that you can run and keep multiple versions of the same application on one machine. Indeed, components can coexist not just on one machine, but even in the same process, you can run multiple versions of a component. Okay. That was a brief overview of the common language runtime component of the .NET framework. What I'm going to turn to next is the supporting class libraries that build on top of the runtime. And again, I'm going to first show you some of the design goals we had when we built the framework. And I think, as has become clear now from the talks you've seen already, our first and primary design goal here is deep integration of web standards and practices. But also, we have worked very hard to unify the various application models that you use to build applications today. And of course, we've worked to make it simple to use, and finally to make it factored and extensible so you can build your own code on top of it. So as you've seen in our talks, web standards and practices are deeply integrated in the .NET framework. HTML, XML, SOAP, XSLT, XPath, et cetera, are key core concepts in this platform. And what it really means is that when you build apps with the .NET framework, they are internet ready. John sort of described the transition that has occurred from the classical client-server model with tightly connected stateful connections between the various tiers to the new model, the new loosely connected stateless web services model. And this transition really affects everything when you design a framework. It affects how you create the base services, what do you do for data access, what do you do for user interface, invocation, programming model. Everything really is changed because of that. So John gave you a slide that showed you a bit about what web services are. I'm going to try and explain to you in a way that I think will be familiar to programmers. When you write applications, there are some application concepts that you use and that you're familiar with. I put them up here on the slide. It's things like data, that are, the data that you have in your app, schema, which is like your schema in your database, or schema that describes what types are in your app. It's services, or rather perhaps functions or operations that your application can perform, and it's invocation, i.e. running the application. On the web, there are today standards, either existing standards or emerging standards for these concepts. For example, on the web, you can describe data as XML. You can describe schema as XSD. You can describe services with the new SOAP configuration language. And you can describe invocation using the SOAP protocol. But you as a programmer probably think in different terms. You know, for data, you're accustomed to using objects. For schema, you're accustomed to writing classes that have, you know, types and members. For services or functions that your application can perform, you write methods. And for invocation, well, you call the methods. Now, what the .NET framework does is it provides you a bidirectional mapping between these concepts that you understand as a programmer and concepts that occur on the web. The .NET framework can take an object and make it into XML for you, or go the other way, take XML and instantiate an object based on what's in the XML. It can take a class and turn it into an XSD schema definition, and go the other way, take XSD schema and create classes for them. Same is true for methods, same is true for invocation. In fact, one thing that I just wanted to mention here, an interesting technical point, is that the way this mapping works is we have in our base class library an XML parser. When you present us with an XSD schema for a web service, what we do is we inherit from the base parser in the framework and then create a custom parser for that particular schema. That custom parser is then compiled to native code. So when you're running your web services, you're actually running native code with a native customized XML parser that fits precisely your schema. And this gives you truly an astounding performance. So I said earlier that the .NET framework unifies the various application models, programming models that people use today. Let me first, take you back to the good old days where, there was the Windows API, and the way you wrote application for Windows was, well, you fired up your C compiler, you included windows.h, you wrote your WinProc, you handled your window messages, basically the old Petzl style of programming. And while that worked, it was neither a particularly productive model of programming, nor was it particularly easy. So over time, what has happened is that various programming models have emerged on top of the Windows platform. For example, Visual Basic pioneered the rapid application development model, where you instantiate a form, you drag controls onto the form, you write event handlers, and through delegation, your code executes. MFC or C++ took a different tack through MFC and ATL. The key concept in there is subclassing. You subclass, from an existing framework. And while this gives you more power and expressiveness, it is not as easy to use. There is not really that same rapid application development metaphor. And then with the advent of the web, we've seen the emergence of yet another programming model, the ASP programming model, where you write stateless code that's embedded in HTML pages. Now, one of the problems with this evolution is that if you look at what's going on here, really your choice of programming model also becomes your choice of programming language, which is unfortunate. If you are a skilled MFC programmer, but you need to write some code in an ASP page, your skills don't transfer. Likewise, if you know about VB, there's not much that transfers to MFC or ATL. Furthermore, there's not really a consistent availability of APIs. Each of these programming models have dreamt up their own solutions to a number of problems that are actually core and common to all of them, like how do I do I/O, how do I do, say, string formatting, how do I do security, how do I do threading. What the .NET framework does is it unifies these programming models. It gives you a consistent API that's available everywhere, regardless of what language you use and what programming model you're targeting. Now, as I said, a design point of the framework was make it simple to use. And of course, a lot of the benefits that I already described that emerge from the common language runtime, of course, apply to the framework as well. But over and above that, I wanted to point out how the code in the .NET framework is organized into hierarchical namespaces and classes that make it much easier to discover where the code is. You know, one of the problems with the Windows API is that there's not really a very good way to organize all of these functions that are available. I suppose we could sort them for you alphabetically, but over and above that, there's not any guidance that takes you, down the right path whenever you're looking for some piece of functionality. The .NET framework provides a unified type system in which everything is an object. This, for example, means the death of variant. Variants are now objects. There is one kind of thing, and it's an object. There is one string type throughout the entire framework. All character data is Unicode, no more ANSI Unicode issues. And of course, the framework is component-oriented. Properties, methods, events, attributes, things that characterize components are all first-class constructs in the .NET framework and the supporting programming languages. And it allows you, of course, to not just build the runtime functionality of components, but also the associated design time functionality when the component slots into a visual designer in Visual Studio, for example. Finally, the framework is factored and extensible. And what it really means is it is not a black box. Any .NET class that exists in the framework is available for you to extend through inheritance. And unlike COM, you're actually extending the class itself, not a wrapper around some internal functionality. And what this really enables is what I call plug-and-play components and subsystems. If you're using the .NET framework, say, in ASP+, but there's a particular part of the system that you need to extend for your particular domain, say, be it in security or whatever, you can inherit from the base classes provided by the framework, create a descendant class that overrides, changes the functionality, and then plug that back into the framework. So there's deep extensibility across. And then I'll stress the point again, there's cross-language inheritance. It does not matter what language you use to extend the framework, or for that matter, what language you use to write components for the framework. So you've seen this block diagram before where, we have the base class library, and then on top of that we have data and XML support, and then web services and user interface. I wanted to show you here that this is not just a architecture diagram. This actually is how the framework is built internally. And to illustrate that, I'll morph the slide here and show you some of the namespaces that are present in the framework. The way you read this slide here is the box that says system is the system namespace. And within that, we have collections, configuration, and so forth. And there's actually a direct mapping between these functional areas we've been talking about and the naming pattern that occurs in the framework. And this, of course, makes it very easy for you to find the code that applies to what it is you're building currently. I'm going to try and drill in a little bit more here. A lot of talks throughout the conference will give you more details of these various pieces. But let me first drill into the base class library. In the system namespace itself, we have all of the base data types for the platform. Things even like ints and floats are defined in the base framework. Arrays, strings, the root object, and so forth. And within that, then, we have a whole slew of various base services that are consistently available throughout the platform. For example, in the collections namespace, you'll find things like sorted lists or growable lists, hash tables, and so forth. In the I/O namespace, you'll find file, I/O, streams. In the .NET namespace, you'll find stuff that allows you to do TCP/IP and sockets, and we have threading, et cetera, et cetera. You get the idea. On top of the base framework, we have the data and XML support. And because of the shift to the web programming model, our data access really introduces some new and innovative concepts. You're probably familiar with ADO and the record set in ADO, which represents a single table. In the new data framework, we have a thing called a data set, which represents multiple tables and their relations. These data sets are completely self-contained data structures that can be populated from a variety of data sources. One data source, of course, is XML. Another data source could be OLADB. A third data source is a direct adapter we provide for a SQL server that goes straight to the TDS wire protocol. But key is that we're talking about a disconnected model, not a strongly connected model. We're talking about using optimistic concurrency in the data set handling. We also, in the data namespace, provide the SQL types namespace, which contains a bunch of data types that map directly onto the types that you're accustomed to when you do database programming, say in T-SQL. Nullable data types, basically, things that can have an int value or be null. Now, in the system XML namespace, we have all of our XML support, and it truly is a world-class set of functionality that we're providing in here. There's, of course, a parser and an XML writer. And both of which are fully W3C compliant. There's a W3C DOM implementation. And then on top of that, we have an XSLT implementation that allows you to do XSL transformations. We have an implementation of XPath that allows you to navigate data graphs in XML. And we have the serialization namespace that provides you all of the core infrastructure for the web services stuff, like moving from objects to XML representations and back. Looking at the web forms and web services part of the framework, in the system.web namespace, first you'll find lower level things that are shared between web services and web UI, like caching, configuration, security, state management, and so forth. And then we have system.web.services that provides you classes to deal with protocols, discovery, and so forth. And then in system.web.ui, we have two classes of controls. And you actually saw them in some of the demos today. There are the controls that give you a direct mapping of HTML tags, like input and so forth. And then there are the web controls that are richer, that allow you to structure them with templates, like the data grid Mark was showing earlier is a good example of that. And finally, in the client UI side, or the WinForms side, we have system.WinForms. And this is, in a sense, a combination of Visual Basic Forms and MFC. It gives you RAD and it gives you inheritance in the same client UI library. So you can build components through inheritance, and then you can visually aggregate them in a forms designer, just like you do in VB. It provides a very rich component model, and it provides a lot of design time support that makes it very easy for you to build new components to slot into the system. And finally, in the system.drawing namespace, you find the implementation of GDI+, which is the next generation of the GDI 2D graphics support in the system. It has exciting new features like alpha blending, gradient fills, texture fills, anti-aliasing, and native support for GIFs files, JPEGs, TIFFs, and all of the web formats. So that's a quick roadmap of the entire framework. It's obviously impossible to cover it all in a short time here, but there are many talks throughout the conference that drill into these various areas. And of course, when you get the bits tomorrow, you can start drilling in yourself and even use these slides as a roadmap. So let me now turn to the programming languages that are built on top of the Common Language Runtime and the class libraries. And let me again point out that the .NET platform is truly language neutral. In the .NET platform, all languages are first-class players. It's not like one language is particularly blessed with one kind of capability and another is blessed with another kind of capability. Rather, all the languages have full access to the platform and you can truly leverage your existing skills. Now, in order to ensure that this really works, we have defined what we call the Common Language Specification, and we've done that in cooperation with a number of key partners. And basically, this is a specification of functionality that you can expect to have generally available in any programming language implemented on the .NET platform. Because the .NET platform is, in a sense, a grand union of all the capabilities of all the possible languages, there are certain features that are ruled out by the Common Language Specification. For example, pointers, because they are unsafe, are not permitted, but of course C++ still has pointers and you can use them internally in C++, or you can expose components with pointers, but then they might not be usable, say from JScript, for example. The Common Language Specification actually divides languages into two groups. The consumer group, which is sort of the easy way to implement a language on top of the .NET framework. And really all that's required there is that you provide access to all of the functionality in the framework. But over and above that, there's the extender group, which are in which we have languages that also permit you to extend the framework by creating new classes through inheritance. Now, we are providing 4 programming languages on top of the .NET framework: Visual Basic, C++, a new language called C#, and JScript. But over and above that, third parties are providing a whole host of languages, many of which you will see at the conference today, ranging from APL to COBOL. And I think this really speaks volumes about the true multilingual nature of the .NET framework. I have a few slides here on some of the languages that we're providing. Of course, there will be talks, extensive talks on these languages throughout the conference. The new version of Visual Basic for the .NET framework is called Visual Basic.NET. And I think the thing that really characterizes that release of Visual Basic is that VB is now a first-class player in the platform. VB Run goes away and becomes the .NET framework. And every feature of the .NET framework is directly available in VB.NET. Now, when we designed Visual Basic.NET, we really listened carefully to the feedback that you've given us over the years. And there are substantial new language innovations in Visual Basic: classes, inheritance, constructors, polymorphism, method overloading, structured exceptions, only one form of assignment instead of let and set, and optional stricter type checking that ensures that you just can't assign anything to anything and have strange things happen. There's also a whole host of new rapid application development features in VB.NET. There's a new XML, a visual XML designer. There's a component designer for business objects and web services, a server explorer that you've already seen in some of the demos, and of course the web forms designer. Another important aspect of this release of Visual Basic is that VB Script becomes full Visual Basic. When you write code in your ASP Plus pages, you're writing in the full Visual Basic language. Indeed, you can actually write in any of the .NET Framework languages. And your code is compiled and executes as native code, not interpreted. So this release of VB really leverages your skills. If you know Visual Basic, this release brings you finally much closer to the internet. We're also announcing a series of managed extensions to C++. When I use the word managed here, I mean code that runs in the .NET Framework as opposed to outside of it. And this release of C++ is really about moving your existing code to the .NET Framework. You simply take your existing code, throw a compiler switch, and it just works, and it becomes managed code. Now, this, of course, doesn't mean that all of your data all of a sudden is garbage collected. There's additional work to do that. However, you get a lot of the features and benefits of the .NET Framework simply by recompiling, like zero impact install, security, etc., etc. Now, managed C++ is still C++. We have made absolutely minimal extensions to the language, only what was required. And what was required we have done in the ANSI spirit. For example, any new keywords that have been introduced all start with a double underbar as specified by ANSI. And we have taken nothing away. And this release really is about giving you power and control. Unique to managed C++ is that it allows you to mix native and managed code to use non-garbage collected data in combination with garbage collected data. And it allows you to gradually migrate your applications. And of course, it gives you full access, like any of the languages, it gives you full access to the .NET Framework. The third language is actually another new language in the C and C++ family. It's called C#. And I'm going to just give you a brief description of the language here, or of the key design points for the language, and then invite you to the talk I'm giving tomorrow called Introduction to C#, where I'm really going to lay out, the whole language and the features in it. C# is the first component-oriented language in the C and C++ family. And what I mean by that is that if you think about what do you do when you write components, you use concepts such as properties, methods, events, attributes, or things that describe how this component hosts in various environments. You have documentation. All of these things are first-class key concepts in the language. They're not naming patterns. They're not separate files that you have to go elsewhere for. Everything is in one place. There are no header files, no IDL, etc. And because everything is in one place, you can take C# code and embed it in web pages like you saw in many of the demos today. C# also has a key tenet that says, in this language, everything is an object. There's nothing magic in this language about primitive types like you would, for example, see in C++, where primitive types have certain capabilities and then classes have other capabilities, and there's really no bridging of those two. And because of this unification of the type system, you'll see that there's deep simplicity in this language as to how you manage and transport any piece of data. And it also gives you improved extensibility and reusability. For C#, we've also focused very heavily on enabling you to build robust and durable software. Of course, garbage collection, exceptions, and type safety are key concepts that are in the language. And since the language is built from the ground up, that's really the only way that you get those concepts deeply integrated into a language. Another thing that we've given tremendous amount of thought is versioning. What happens when you build V1 of a component and then you build later V2, V3, V4, and the base class library underneath you is also evolving, and what do we do to avoid version conflicts and incompatibilities and so forth? And then finally, C# is about preserving your investment. It has a very close heritage to C++. It is, of course, about simplifying C++, but not about needlessly throwing away features that that you know and make good use of. Another key thing to preserve your investment is providing great integration with existing software. And we have great integration with COM, and we have this feature called pinvoke that you'll hear more about that allows you to easily call existing code sitting in DLLs. And we even have a feature called unsafe code that allows you to turn off type safety subject to security restrictions and get directly at pointers and native APIs. We have millions of lines of code written in C# in the .NET framework, and people are consistently reporting to us that if they programmed in C++ before, it's a short learning curve and they find themselves to be much more productive. And as I said, I invite you to come to my talk tomorrow and hear more about this exciting new language. That was sort of an overview of some of the core components in the .NET framework. And what I'm now going to do is I'm going to turn it over to Dave Mendlen, and he's going to come up and demonstrate for you some features of Visual Studio. What better way to see those than actually demo them? Thank you.
Great job, thanks.
I'm back. I want to talk about Visual Studio.net. We think of Visual Studio.net as the most comprehensive tool for rapidly building these enterprise web applications. And yes, we're concerned about building high productivity tools that work when you're working in teams as you're building your web apps. Obviously, we want to go end to end as you build these web applications. And you saw in the demonstration this morning, we're building user interface and middle tier logic and interacting with back-end databases. And you have all the tools you need in terms of life cycle, all the way from the process of conceiving of an idea all the way through to deployment with Visual Studio.net. Now, they told me that I had 30 minutes and I had to get the crowd cheering. I can't think of a better way to do that than just show Visual Studio in a demo for 30 minutes showing off the top 30 features. So that's my plan. Now, there's a lot of developers in the audience that built Visual Studio.net. So if you find a feature that you think is particularly cool, let them know. Give them a nice round of applause. The demo architecture that we'll be walking through, this is the app we're going to build, it has a user interface. It's an online travel agency. And we'll be walking through the construction of web services that this travel agent might use out on the internet. One of them might be a points of interest, so that when you identify a travel package in, say, Lake Tahoe, it can list for you the best things to do in Lake Tahoe, like go golfing, or the best restaurants. We're going to build that web service in C#. Then we're going to jump into looking at our RAD designers with building a hotel web service. So you can book the best hotels based on your budget and the hotels that you have club membership to, for example. We'll build that in Visual Basic. And, of course, you need to book your airlines, and we'll create a web service using ATL server to, based on your frequent flyer numbers and the place you're going to and your budget, we'll give you the best airline. And then, of course, we'll have some other web services you'll see as well. So let's start demoing. This page that you're seeing right now is the Vista Vacation online travel site. And right now, this site doesn't do a whole bunch because we haven't yet created these web services. These other third parties haven't built them. We're going to build them in all those various languages. We're going to come back, tie them back to this website, and you'll see a more interactive experience. I think the next generation of an internet user experience. What we'll be able to do is capture we have a lot of information about customers based on our own portfolio or profile of that customer. They've entered their own preferences. And what we can do now is we can tie that in with the choices they make about the trip they want to take, and we can provide back the best travel package. So let's get into Visual Studio. The first thing you see when you start Visual Studio, and I should mention that I think Visual Studio.net is the ultimate developer cockpit. It knows about the way that you work and adapts to the way that you work. As you can see, I have my environment set up. When I go to the Visual Studio environment, there's this start page. It's a developer portal. And the first thing you're probably going to want to do when you start Visual Studio is tell it what type of developer you are. Now, as a Visual C++ developer, I know that my Solution Explorer should be in the upper left and my properties in the lower left. And my keyboard mappings, F11 is step for Visual C++ developers. We've got all these languages in the same IDE. What about if you were, say, programming in Visual Basic? Well, you simply go and choose the profile that makes sense based on the type of developer that you are, and we'll reconfigure the environment to look the way that you work, and we'll actually change the keyboard mappings to work the way that you work as well. Now, this start page is actually very, very powerful. It uses web services. It goes out to MSDN Online and captures information based on this profile that you've just selected and caches that information locally. Everything from online community, it'll recognize the news groups that are relevant to VB developers, to headlines. The MSDN headlines will actually come down locally, cache these articles, will exist offline, so you can work, if you're working in a disconnected way, you can check out the news that's relevant to the developer. In this case, the VB developer, you just go out online, it'll bring back the articles that are relevant to you, and you'll have them in a disconnected way. So as you can see, Visual Studio is really the ultimate developer cockpit. We've got all these languages in the same IDE. We've got this integrated web service that goes out to MSDN and is providing all the best information to you. And it changes, it adapts to the way that you work. And one of the ways that it adapts to the way that you work is you're really concerned about screen real estate. I know I am. One of the things you'll notice is that we have this expanding and collapsing tool windows. So you can pin these things and you can leave them in place as I have my Solution Explorer and my Properties window. But if you want to use it in this manner, you go use something that you want to use and then move your mouse away from it and it will just hide itself away. Now let's take a look at, so we've just shown you, a very productive development environment customized to the way that you work. Let's take a look at programming in C#. And now what we're going to be building is that web service that, the web service for C# was the points of interest, so that if you went to Lake Tahoe, it would give you the list of best restaurants and best activities in that area. And what I'll do just immediately is, one of the things that you typically do, probably like I do, is you write your code, and then afterwards you have to go back and document it. Now with C#, you can actually document while you're writing your code. You saw I typed in 3 slashes, and it automatically created this XML summary section that I can type in documentation about this particular function. Loads data set. Actually kind of a weak description. What happens when I compile this application is it'll actually take this document and persist it out to an XML file, so that all of my comments are now in a central location in a structured document that I can use as my documentation for my application. Now, I've obviously not completed this documentation. I need to come back and fix this. So one of the great features here is we've had C# developers, as well as other developers in this environment, have the ability to type in to do and actually remind yourself, document this function. And now I can remind myself, I go back and look at all the things in my task list, and I can just simply double click on that task, and it'll take me right to the line of code that I need to go back to and make modifications to. So we've actually just finished building the C# component for our web service for the points of interest. And as you can see, C# is and Anders already spoke about C# being the first component-oriented language in the C and C++ family. It's really about productivity. You have full access to first-class properties, methods, and events. So now let's jump over and construct another web service. Now this web service will be a C++ web service, and we've talked a little bit about ATL server. Yep, I'm in the right place. So we've talked a little bit about ATL Server. The web service that we're going to be building is the airline reservation web service. And for those of you that are familiar programming in ATL, you've heard in April of this year we announced ATL Server to make it very, very easy for you to build the highest performance web applications, getting right down to the metal. Now we've also got the notion of attribute-based programming. And what that means to you is that you're going to have to write less code as you're building these applications. And to give you an example of this, I'm actually using an attribute called the SOAP method. And just by declaring this function declaration with a SOAP method, Visual C++ will create the plumbing that's required to both call and receive SOAP messages. That's all you need to do. Tag your function as SOAP method, and when you compile your application, it will be exposed as a web service. So you can see that with C++, native C++, with ATL Server to build the fastest performing web applications, and with attribute-based programming, native C++ developers will be able to build the same kinds of .NET applications that the other languages on the .NET platform have. Now, let's talk about the rad designers that are a core part of Visual Studio. Generally, when you're building middle-tier business objects, and now these web services, when you're building these middle-tier objects, it requires a lot of code. You know this. You spend a lot of your time in the middle tier. Now, what if you could take the notion of rapid application development that you know building user interfaces with Windows and apply that to building middle-tier business objects? Well, that's what we've done with RAD for the server. And there's two pieces to RAD for the server. There's the component designer, which is a visual class that you see here in front of you. And there's the server explorer. There are really two parts of the problem with building these middle-tier business objects. One is, of course, reducing the amount of code that you write with visual components. And the additional problem that we're trying to solve is getting access to server-based resources. Often, to build these middle-tier objects, you're working with performance counters and event logs, message queues, and exchange servers. And so now we have a central place, one location to find all those server resources on your corporate network. And it's called the Server Explorer. So that you as a developer can go here and find all of those things that you need to get access to. Now I'm going to go ahead and build an application using an event log so that if I have any errors, I'll write those out to the event log. And you see that I can simply find something on my network and drag and drop it right into my environment. That actually did quite a bit of code. I'm going to actually drag and drop some performance counters as well. When my web service gets hit, I want to increment my bookings performance counter, and I want to increment my browse hits. Somebody's actually hit my web service. So I've just dragged and dropped 3 objects. They could have been message queues or exchange servers. But you can see that it's very easy for you to construct these middle-tier objects. And we've made it simple to program against these middle-tier objects with the .NET framework. So if I were to go into code now, I've essentially built the infrastructure that's required in order to use these objects, to use these components, these server resources. But now I need to write the code that ties these things together. And just to give you a sense for the amount of code that you have to write, here you see I've got those 3 objects, and it really only required 3 lines of code to write to 2 performance counters and an event log. And it could have been any of those server resources. You still get a very, very minimal amount of code that you need to write. And why? Because the .NET framework, the classes that Andrew spoke about earlier, have greatly simplified the process of working with these server-based resources. So that's RAD for the server. We're trying to greatly simplify the process of creating these middle-tier business objects. Now, I've shown this in Visual Basic, but it's important to understand that this works with any of the languages that are targeting the .NET framework. Let's talk about, we've essentially built this middle-tier business object. Let's talk about the back end. Let's talk about data. Today, you're all familiar with the Visual Studio 6 database design tools. It's a tool that lets you both view and modify your schema for relational tables, relational databases like SQL Server or Oracle. And what we've done is we've taken the best of that and we've actually extended it even further. We're taking advantage of the next evolution of ADO, something called ADO Plus. Now, ADO Plus is really a natural evolution of ADO, using the notions of the skills that you already have, creating connections and commands, and you know about record sets. Well, we've essentially taken the notion of a record set, and we've got this alternate implementation called a data set. Now, a data set is a stateless cache of XML. Now, the benefit of having this XML-based data set, first of all, is because it's a stateless cache, it's very highly scalable. And because it is XML, unlike a record set, you can actually pass a data set to another platform, say on Unix. They can manipulate that data, return it back to you, and you can continue to operate on it as a data set. So to give you a sense of how you might construct these data sets, here is the design surface for building a data set. And basically, all you need to do is go up to the Server Explorer if you want to use a relational database. You can, of course, create data sets with relational databases like SQL Server or Oracle or some other relational database. You can also source these things just natively from XML or just arbitrarily create your own data sets out of there. Now, I'm going to drag a table out of my SQL Server database and just drop it right onto my design surface. And it's represented that table, just as you might have seen in the visual database tools, in a visual way. But what's really going on here is, if you switch, I'll switch over to an XML view. This is really represented as XML. In fact, we've got this first-class XML designer that not only has color-coded syntax, as you can see, we also have XML statement completion. So as I open an angle bracket, it actually gives me all the relevant tags. And it has context about what I'm doing. So that is a really great feature, that statement completion. So we've just built a data set, and this data set is connecting to the facility table is a hotel table. Remember, we're building the hotel web service. And now I'll simply close and save this, this data set, and I'm ready to start programming against it. And here I'm looking at some code where I want to actually use a data set. And one of the things you'll notice about ADO Plus is that it leverages the skills you already know. It shouldn't be a big shock here. We have a connection object, and we have a command object. And now the beautiful thing about ADO Plus is that you can actually define new instances. We're using what's called strongly typed objects. And what that means is that now you can actually dim up a new instance of your data, but instead of looking at tables and columns and fields, you're looking at your objects, your business objects. We're strongly typing against the table that you're working with. Now, the benefit here is, first of all, it's going to make your code much more maintainable. Instead of looking at, again, instead of looking at tables and columns and fields, you're looking at your objects. Additionally, you'll find that this is going to perform much faster because at runtime, when your application is running, you're not having to iterate through the collections of tables and columns and fields and values. You can actually go right at the object you're working with. So this is the facility table, or I can reference directly one of the columns in the data set. So you can see that there are these great rad designers that are just core to Visual Studio, and the two that we've just seen are the rad for the server designers with the Server Explorer and the Component Designer, and you've just seen using the ADO Plus dataset designer to paint a data set that you can then call directly in your applications. Now, let's talk a little bit about the Visual Basic Language. And I will go to another website. Now, we're actually going to start building the user interface of our application here shortly. This is the infrastructure code for our website for Vista, for the Vista travel site. And we're looking at a set of code that's actually calling into a data set. You never really know what code is going to work, what isn't going to work. So I'm going to actually take advantage of one of the new features of visualbasic.net, and that is try catch. Structured exception handling is going to make it very easy for you to modify your code. You can actually centralize your error handling code in a single location. So I'm actually going to raise that exception out to a single location. This is going to make it a lot easier for you to build your applications because you can centralize your error handling in a single location. No more having to write on error go to ever again. So, structured exception handling core to Visual Basic. Let's take a look at some of the other features in the Visual Basic language. You saw in the keynote this morning that we showed cross-language inheritance, and to give you another sense for that, in this same application, we have developers, again, working in another language, in this case, C#, and they've built a component called pricing, and they've got a base class called base price. Now, this developer has built the tax calculations and the total pricing for a travel package, and I don't want to rewrite it, even though I'm writing here in Visual Basic. So I can simply type in inherits pricing.baseprice, and I'm actually doing cross-language inheritance. Not only does Visual Basic have inheritance within itself, it also inherits across languages, as do all the .NET languages. Now, once you've got this a reference to your base object, it makes sense for you to go and extend some of the functionality. So some of the other things that we've added to the VB language are things like overloading and overriding. Visual Basic has become a first-class, object-oriented programming language. So we finished constructing the infrastructure for our website. Now it makes sense for us to show the user interface. Let's take a look at what you might do to build a web application. Now, you saw this morning the construction of a web form, and you heard with Mark Anders the discussion about ASP+. And we have this WYSIWYG design view. This is the shared WYSIWYG design tool that you may have seen in Visual InterDev. That's now a core part of Visual Studio, so that regardless of the language that you're programming in, you have access to this web designer. And there's a lot of advances that we've made to this designer, everything from HTML statement completion to absolute positioning for HTML 3.2 pages. But one of the most interesting, I think, is the ability to target a browser. We actually have the ability to choose which type of HTML you're going after or a particular browser. And this list will flesh out as we ship the product. We'll add more and more browsers to this list. What's great about the way that we've implemented this ability to target a browser is that it's a pluggable infrastructure. We're using a DTD, or a document template definition, so that as you as a developer may find another browser out there that's got a DTD, you can drag and drop that file right into a directory in Visual Studio, and it will show up right here in this environment, and you can target it directly. What we're going to do now is we're going to construct the user interface for one of the pages on the Vista Vacation site. Now, of course, Microsoft will be shipping a number of web form controls and HTML controls to make it very easy for you to build your applications. But we've been out evangelizing to our third parties, to our ISVs, our partners, and they've already started to come online with building web form controls. You should see a whole host of them when we ship the product. One of the thought leaders in this area is Seagate. Seagate Software has built a Crystal Report. I'm sorry, I was in the right place. Seagate Software has built a Crystal Report web form control so that you can simply drag and drop that onto your design surface. Now, unlike a traditional report, a print-based report, Seagate has taken full advantage of the .NET framework. And not only can you view a report, and I'll select a report and it'll show up real time in my environment. Not only can you view a report, you actually can drill into this report. It has properties, methods, and events, so you can actually make it a very interactive experience as you work with this particular control. And we'll see using this web form control when we run the application here in a few minutes. We showed you in the keynote this morning that we also target mobile devices with the adaptive UI piece. So here is a mobile form that we've built in Visual Studio. And again, we're targeting lots of different devices here. And in the example that we'll show here, we showed using cell phones earlier in the day. We'll show using some other mobile devices here in a moment. So as you can see, as a developer, when you're building these web applications, you have all the tools you need to assemble them. You have, of course, all the intrinsic controls that Microsoft ships, this rich web designer, and of course, the ability to target any device. It's going to be very easy for you to build applications that run on your desktop, offline, or even on your mobile device. So let's now run the application and see if it works. We've built web services in C# and VB and an ATL server. Let's see if this thing works. Oops. I have this. Unfortunately, I have to fall back to my other machine. Let's see. Oh, that worked. All right, so here's that site. What we're going to do now is we're going after the weather. I'm sorry. What are we escaping from? Are we escaping from weather or work, your children, city life, country life, your school? No, it's really hot here. I'm going skiing. So I'll click on that and it will escape off to go do something. And one of the things that you saw, we dragged and dropped a crystal report onto our design surface, and now we can actually drill right into that report and look at one of the comments that was made. So this report actually is giving back. People have come back from their travel package, from their travel destination, and said they liked this travel package or they didn't. And here are the comments that were offered up. And that was all part of the crystal report that Seagate offered. So now that we've identified that we want to go to Lake Tahoe, let's take a look at the itinerary. And what happened just now is it went out to those web services, all three of them, and identified the best airlines, hotels, and the best places to go. And now we can actually go looking through our application. Unfortunately, what I would like to show you right now, but as you saw, I had a little problem. Wanted to show you end-to-end debugging of the application. We now have debugging in client-side script to server-side web form controls to middle-tier objects across languages back into the database and back. We can debug end-to-end with Visual Studio. So let's go ahead and book this trip. And you can see that at the end, I need to make some choices about where I'm going to go. And one of the things I need to choose is my reservations for where I'm going to dine. So I'm going to click on dining options, and I'll pick Eat at Jim's and save that. And now I've made all my modifications. I'm ready to continue on. But what I want to do now is let's switch over to the mobile device. Can we switch over to the Elmo? Okay, can you guys see that? So we're looking at a wireless device. It's a pocket PC. And we're going to show is using that mobile form to interact with our application on a pocket PC. So let me zoom right in here. I think that's about good. So let's take a look and change the restaurant that we just picked. Oh, it's asking me to log in. Username, no password. I have tight security here. So I'm going to go into Lake Tahoe, and I'm going to modify the itinerary here. So you can imagine that I'm driving home from work after booking this travel package while I'm at work, and I realize, I don't want to have nachos or chili while I'm on vacation. I'm on vacation. I want the best. So for lunch, instead of having nachos and chili, why don't I have How about steak? So I'll go ahead and modify that restaurant that I chose. And this is going out real time over the internet, as you can see in the URL, out to a public internet site and calling this exact same code. And I will choose steak. So I'll go ahead and say yes. I definitely want the blue beef steak. I have a very fast internet connection, as you can see. We'll give it a second. You know what? I think we've proven the point. Maybe we may come back here if this ever comes back from wireless hell that it's in. Let's come back to our Vista Vacation site. There we go. Now what you're looking at is a products page. We've just finished completing a typical transaction. When you go to a travel agent, you might actually want to buy, you want to book your hotel and your airlines. You want them to give you the best places to eat. But do you expect when you go skiing for them to recommend skis and gloves? So this is one of the things you might see happening with web services, the ability to work with your partners to provide better customer opportunities, a better customer user experience. And what's fascinating about this web service is that it's actually running from a Unix box. Can we switch to the Unix box very briefly? There you go. So that Unix box right there is actually serving up their Corba components that are exposed on Unix. Now, what's great about this is that we've actually identified exactly how to build web services on Unix, and we've published white papers and sample code. It's up on MSDN. You can download this today. Let's go back to our application and finish up. Can I switch back to Windows? Thank you. So I'm going to go ahead and continue. And you can see that we've finished booking our travel reservations. And what you've seen in this presentation, VisualStudio.net is the ultimate developer cockpit. It's got a start page, a developer portal that uses web services to go out over the internet and bring down the best of MSDN. It changes the way that you work based on the way that you work. You can change your user interface, the IDE. It can adapt to the way that you use the real estate on your screen. You've seen C#, the most productive language in the C and C++ family, with first-class access to objects and the ability to persist your comments out as XML. You've seen C++ and our commitment to native C++ developers to take full advantage of web services with ATL server and attribute-based programming. And you've seen VB's and really Visual Studio's RAD for the server and the ability to compose ADO plus data sets. XML as a stateless cache of data that's highly scalable and provides you strongly typed programming for maximum performance and easier maintenance. You've seen the Visual Basic Language with structured exception handling, with full inheritance, with full object-oriented programming. You've seen the construction of a web user interface with web forms and third-party controls and the ability to target mobile devices. It actually did come back, by the way. The ability to target mobile devices that are run on pocket PCs, on cell phones, and other mobile devices. You can debug applications from end to end. We've got rich WinForms designers that let you build Windows applications that lets you call directly into web services. I wasn't able to show you that part of the demo because I'm being kind of waved off the stage. But you can build Windows applications that can call into web services directly. And not only that, those Windows applications, those WinForm applications, have visual inheritance. So you can create a base form and visually inherit from that form. So as you can see, with VisualStudio.net, you have all the tools you need to build the applications that will power the next generation of the Internet. Thank you.
Ladies and gentlemen, we'll be taking a very short break and then back with Richard Jenny.